Hello and welcome back to the channel. This is the part 2 of the series for football data engineering. If you have not watched the part 1, I would recommend before continuing to watch the part 1. You will see the link in the description below. But if you have, let's go into this part where we are going to be getting the data from Apache Airflow into Azure Data Lake, and we can continue our processing on the cloud. Now that this part is potentially done, the next thing we need to do is go to our Azure portal. If you don't have a portal, if you don't have an Azure account, you can go to google.com and you can say on Google, you can say Azure free account. And with this, you can get your free account today. But I already have an account, so you can start free and create your account. It's going to request you to put in your credit card information. Once you do that, you are going to have a free access to that. So I think I'm going to go into the dashboard that I have, into my dashboard. So on the dashboard, I have you see several UI and all that, but what we are particular about right now is there are two things. We have a storage account and the Azure Data Factory. So if you don't know where to go, the first thing you can do is just come in here and search. So I'm going to start with a storage account, which is this services storage accounts. I already have a storage accounts there, so I just need to create a new one to show you how to do that. So I'm going to, so it's asking me to put in this data, and you can see I have a subscription here. So if you have a pay as you go, you select a subscription, but if it's your free account, you should see something like this. And right now there's a resource group. I'm going to create a resource group for myself. I'm going to call it football data engineering. I'll call it football data engineering, and I'll add a resource group to it, so to differentiate the different services. It's just my style. You don't have to do it like this. You can call it any name you want. So for me to just remember or identify easily what each of the services are for, that's why I added that. The storage account name, I can have football data engineering storage account. Data engineering. I think I'll say, yeah, I'll just leave it like that. Your region, if you are in any part of wherever it is, you are just select somewhere close to you to reduce the latency. I'm going for the standard, the redundancy to have multiple replication. You don't need to do this, but you can have a redundant locally. But because we're not doing anything too critical, so I think we can leave it as geo-redundant solution, so you don't have to worry so much about that. We have a REST API, allow anonymous access to individual container. Nope. Storage account key. Nope. Default this hierarchical namespace. So this is just to allow you to access it, just like you have your document. Inside your document, you have a folder, something like that to navigate on the UI, something like that. I'm going to check that. Enable SFTP. Do we need that? No. Let's see. No, we don't need to access this via SFTP, so it's okay. We have a blob storage SSTR is going to be hot, so it's okay. Because it changes frequently. But if you have data that is not going to be changing frequently, you can choose the code. Public access from all network, Microsoft network routing, good. Self-delete, everything is pretty much a next thing. Just next, and next review, and anything else, create. And by creation, we have a storage account that we can use. So I just need to go to the resource. Now in my resource, on the left side, you have different activities, which is the activity log tags and the rest. We have the storage, data storage section. We have security and networking, data management. So for each of them, this is more like a shortcut to each of the services. So for the storage, you have a container where you have all these files stored, just like your documents on your local computer. the file shares where you put data there and you share with people individually or group. The queues, the tables, you have the security and networking where you put in the IP addresses, the people that are going to have access to the system. The keys where you put in the access keys and the rest. So each of them have the different options. You can go through the Azure documentation for more details into that. So we're going to be particular about the containers because that's where we want to work with. Right now we don't have any container. I'm going to create a container. I'm going to call it football data engineering. It's no anonymous access. I'm going to create that. So it's just like creating a directory on well, not a directory, more like creating you may have a directory on your local system, but this directory is like the root directory. Okay, so inside this directory you can now create a directory. You can upload files to that, if that makes sense. So I'm going to have let's say I'm going to call this data, and I'm going to add another directory. I'm going to call it ready. All right, so when we push data into Azure, we're going to push into data. By the time we are done with the data, or we want to process the data further after the initial processing, we push the data that has been processed into ready. Okay. All right. So now going back to now that we have this ready, I just need to come in here. We'll just come back in here and we go into our root directory, the container, which is this our storage account. So we need the access keys for us to be able to access or put data into this storage account. I'll just click on show and I'll copy this. In here, when I'm writing, so instead of writing to this directory, I'm not going to be writing to a directory anymore. I'm going to be putting this key just here, and we need a particular package on our system to be able to push data to Azure Data Lake, okay, which is the ADLS package. Pip install ADLS, ADLFS, okay. So this is the Azure Data Lake file system. This allows us to push data into Azure storage account on our system. So instead of just data to CSV, I'm going to our local system. I'm going to have data.to CSV. But the way we do this is a little bit different. The format is different because on Azure storage account, they are using something like Hadoop, where you have the Hadoop file system, something like an HDFS. But this time around, they are using a protocol called ABFS. Now, so what is happening is this. We have the container name, which is this guy. Let's see our container name. This is our container name. If some might argue, maybe I can change the name. It's fine, but I just choose the same name. It doesn't really matter what I choose. I can change this to name to something like Football Data Engineering C to show that it's a container, but it's fine. It doesn't really matter. But what matters is your container name, then your storage account name. So this is going to be container name, storage account name, and this data in here. All right. So once you have this and you've installed your ADLS, ADLFS, so I just need to come in here, put that into requirement.txt so it can sync with our Docker containers. Then we can do the installation on the server. I'm going to have pip install requirements.txt. I'm going to run that. and I'll go back into my scheduler, the exec section. I'll do pip install requirements.txt, and that should potentially install the Azure Data Lake file system service on our system. So good. So once that is done, I'll just come back in here on the UI and I'll trigger this again. And all things being equal, we should be able to see our data inside Azure Data Lake service in our container. All right. So let's check if we have the data on Azure. So if we check in here in our storage account, we go into our container, go into the data, you can see our stadium claimed sitting there pretty nicely. Excellent. So now that we have our data in here, so each time we run our processing, we're going to be having a copy of the data on Azure. So that's the part one. The part two is to go into our Data Factory, Azure Data Factory. So I'm going to have Azure Data Factory, which is here. So if you don't have it, you can just search for Data Factory. You can see Data Factory is here. We need to create another Data Factory to demonstrate that this is working. So we are going to have an Azure, you select your subscription here. We already have a resource group, which is a football data engineering resource group. So we don't need to create a new one. So we are going to have football data engineering, and this is going to be our data factory. All right. So the next, we configure Git later. Good. I'm going to have a public endpoint, which is good. It's fine. Advanced encrypted. Nope. It's fine. The tag. Nope. Review and create, and then we can create. Now our deployment is complete. We can now go into the resource for the data factory. Now coming in here, we need to launch our the data factory studio. This is where we'll be doing another level of manipulation as we discuss in our architecture. Now we are now in the data factory section. We have different aspects. This is the home, of course, where the dashboard is. We have the author, where you can write your pipelines, your data sets, your Power Query, data flow, and another feature that just came out, which is the change data capture, the CDC, where you listen for changes at the log level for any of the services that is supported. We have the monitor section, where you look at the performance and the more like your report of what has happened, like the triggers, the pipelines that has happened. We have the manage section, and we have the learning center. One other thing that I want to show you is this Apache Airflow, which is the orchestration manager that is supported on Azure. But the challenge that I have with this, we could have used this as our Apache Airflow. The challenge I have with this is the changing of our code each time we want to run. That is going to take a lot of energy to keep uploading, changing, uploading each and every time that we want to do that. But at the end of the day, we can do a test run on this managed Apache Airflow. It's really simple and straightforward. We just need to create a managed Airflow account and then upload your DAX into it, and that's it. But we're not going to be going there for now. We just focus on the offer section where we can connect to the different pipelines and the rest. Okay, so we have a pipeline section in here, which is a pipeline here. We can create a pipeline. So this pipeline, what we want to do basically is we want to get data from our from our container. We want to go into, I'm going to just go into our storage account. So I can show you, we have football data engineering. We are going to go into the container section. In our container section, we have our football data engineering. In our data, so in our data folder, that's where we have our stadium cleaned, okay, with the timestamp and all that, okay. But what we want to do is we want to push this particular data. We want to push it into our ready. Okay, so if you just click here, I think I clicked too fast. So we want to push data into the ready folder. All right. So at the end of the day, whatever file we have in our ready section is the file that we're going to be performing analytics on. So coming in here, we're going to have a move and transform, which is our copy data. So what we want to do basically is to copy the data from the data section into our ready section. All right. So in here, you see the source and the sink. This is where the connection is coming from, and this is where it is going to. So for our source, I'm going to just hide all of this. For our source, we just create a new source because we don't have any source already. So we have different sources. Most people just maybe have their files on GitHub and use the HTTP to pull data in, but we already have our Airflow pushing data into our data lake, our container, which is fine. So we just need to go in here. We search for Gen 2, which is I'll just Gen 2, the Azure Data Lake storage. I'll click on that and continue. The format of the data that we are bringing in is a CSV. So I'm going to click on continue. It's a CSV and I'll call it stadium cleaned with timestamp. All right. So we don't have any link service yet. So we just need to create one. So this link service is going to be connected to our storage account. So we just need to find our storage account in here, which is the football data engineering. We click on that and that's it. We just, okay. And we've linked our storage account into that. So we just need to find the file that we want to bring into our data lake. It's pretty much simple. You just click on the file and then click on OK. The first row is the header, of course. We don't need any schema. So we go, we select none on that and we click on OK. Right now, we have our data. If you do a preview, you can see our source data. This is our source data, which is here. But there's an error. There's a prop 0 in here, which is not. It's because we just exported it. We didn't ignore the index option. Okay, so we just need to, when we are doing it to CSV, we do index equals to false. And I think we will rerun this in the background while we continue our processing. Okay, so we don't waste too much time on that part. I'll just refresh. So that is done. I'll trigger the flow again. So it goes on in the background and it keeps running. So while we check, we continue our processing on the data factory. Is it triggered? Yes, it is. Good. So we go back to our data flow. We don't need this prop 0. Okay. But the rest of the columns are pretty much needed. We have the home team, we have the location, which is good. So the next thing we want to do now is we want to service this sink where the data is going to be going into. So we don't have any sink yet. We create a new sink. It's still the same Gen 2. We click on the Gen 2, which is this guy. We click on continue. We click on continue. What am I doing? I just toggled it off. Yeah. All right. So we're going to be pushing the data in a CSV format. I just select CSV and I click on continue. All right, so what is going to be the file name of what we are going to be saving? We're going to be saving it as stadiums cleaned. We are not adding timestamp to that. Our link service is the Azure Data Lake storage, and we're going to be putting that inside the ready section. Okay, we're going to put it into this part, and no data there, and then the file name is going to be stadiums cleaned.csv. That is the destination file name. We don't need the schema, and we just click on OK. So right now our source and the sink have been validated. So we have been configured. We just need to validate to see if there's any error. Right now we don't have any error because it says your pipeline has been validated. We can close this and we can run this. Okay, so I just do a debug and see if we are able to copy that data from that particular source to our ready folder, which is the destination. Okay, so it's done, and we can check in here. Let's see if we have the data in the ready, and you can see our stadium clean. We have the data. Now, if we have multiple data or multiple CSVs or data sources, we can join them. Once one is done, on completion, we do something. Once fails, we do something else, and you can run them independently to run in parallel, so you don't have to specifically trigger each of them. But that's how it is done. What I just need to do is do publish all, so we can save these changes. We have our pipeline, our data set. This is with timestamp and this is with clean. Okay, I'll publish this. So let's check the progress of our Airflow transfer. It's almost done. It takes about 4 minutes. I think the maximum time is 4 minutes. Yeah, 4 minutes 02 seconds. And it's already done. Excellent. So now we can see that the data is being pushed into Azure, which is the last bit. Yeah, it's done. So if you check our data lake service in our container, and we check our data, you can see the latest data, which is this one, which is the latest one, 2237. And in our data frame, data factory, I'm going to change our source. I'll just click on this and I'll open it. So I'll change the data source from the initial one to the latest data frame CSV, which is the 37. I'll click on OK, and I'm going to validate all and publish all. Yes, it's edited and published. So if we check this out, we shouldn't see the prop 0 as part of the data, which is fine. Perfect. So we have the rank, stadium, and the rest. Excellent. So this is how you can use your data factory to do the manipulations and data migration. So let me know in the comment section if you want a more complicated flow on the data factory. There are multiple architectures you can build on this, so you don't have to do so much in the background. So just let me know in the comment section if you want that. So once that is done, the next thing we want to do is we want to play around with this data to see if we can perform some additional stuff. So there are two ways to that. You can decide to use Azure Synapse analytics to play around with the different aspects of the SQL part, or you can go through the Databricks part, which is where you do the Python programming. You use Python to manipulate the data content, just like you have your pandas, but this time around you'll be using the Spark. All right. So we can either use either of the two, but I think since we have our data properly cleaned up using the Airflow routes that we took in the initial using Airflow, so I think we should probably go through the Azure Synapse directly. So we just continue from there. But let me know. We can have a more elaborate session on Azure Databricks and how to use other systems with it. All right. So going back into our dashboard, I'm going to go into the dashboard in Home, and I'm going to come to Synapse, and I'll call this Synapse Analytics. I'll go into the Synapse. I'll create a Synapse Analytics workspace. So selecting the workspace, we have Football Data Engineering Resource Group, which is the one we've been working with. I don't need the manage resource group name. The workspace name is going to be Football Data Engineering, and I'm going to call this Synapse Workspace. In fact, Synapse Analytics Workspace. The account name is going to be Football Data Engineering, which is the data engineering. Then I go to next. So if you want to have a password, you can put it here. I don't need a password, it's fine. It's just to quickly do that. Network access to Gen 2 storage, we don't need that, it's okay. Next, manage virtual network, disabled, is okay. Tags, next, and create. I'll just do a quick review. It costs $5 to create it, and I'll just create. So you don't have to worry so much, because if you are using the free trial or free subscription, all this comes in with it. So it's just going to be deducting from your credit. But at the end of the day, if you are using a subscription, you might want to be watchful. If you have a Synapse Analytics before, you can reuse it as many times as possible. But because this is the first time on this tutorial, that's why I'm creating a new deployment. You don't have to do this if you already have an account. I mean, if you have a workspace already that you've been using, so you just have to maybe create a new shared workspace inside it. I think it takes a few seconds for the deployment to be done. All right, the deployment is completed. We can now go to our deployment details, which is what we have in here. Go to the resource group. So we have our Synapse. If I click on Synapse, it takes us to the workspace, and we can go to the Synapse Analytics Studio. Okay, open. Now with Synapse Analytics, we can run SQL statements on using PySpark, using Apache Spark on our data. We just need to bring it into our Spark pool, and from there we can easily run our scripts from there. So we have on the left side, we have our data, we have the develop, integrate, monitor, manage. Okay. So for the data, this is where all the workspaces is. You have your SQL. If you want to do some connection, the lake database, which is what we'll be doing. The develop section, where you can use your scripts to work with the data. The integration section, where you do the same thing we did with our Azure Data Factory. You can easily do it in here too by creating a pipeline and the rest. The monitor section, where you monitor the performance of the systems, the pipeline runs and the rest. Also the request and maybe the time it took for each of the requests that you make. and the manage section where you configure each of these stuff. So we're going to be going into the develop section, and then we can have our SQL script. In this SQL script, it's going to be running on this, but we don't have any database connected. We are not connected to any database. So even if we run anything, it's going to just be normal query. You are just typing queries. So we need to bring in the data that we want to use. Okay. So we are going to be bringing data from the Lake database. Of course. Okay. We need to bring in data. So this is a database. I'll call this stadiums database. Okay. And we don't have any table right now. So we need to import the table that we are going to be using. And how do we do that? I'll just collapse this. We come in here and click on table. We select the from Data Lake. We don't have a table name, so we call this stadiums. Then the link service that we're going to be using, we have football data engineering, Synapse analytics workspace, which is what we created the other time. And we have a input file. This is connected to our container. We have already, and we have stadiums cleaned. All right. So that's where the input file is going to be coming from. If you select OK, reset. Yeah. If you select that, it's going to be doing a preview and importing the table into our database. More like a temporary view of the table that we have. So we can infer column names in here because the column names are going to be there, but it says you couldn't detect. It's okay. Yeah, it's fine. You couldn't detect it. It's okay. No problem. Our column is okay. We have a comma, empty string, and the rest. It looks like maybe we can preview. I'm going to cancel this. Discard and add the table from Data Lake. We have a stadiums, link service again, impute data. Let's see. We need to do a preview of the data we have in there. Okay. Continue. Yeah, let's preview the data. So we have no, the rank, the stadium. So it looks like this. Yeah, it looks like we still have this empty column, which is weird. I think we already fixed that, didn't we? Yeah. So I think the 37 didn't have that. So the integration that was being done on the old data. So we need to pull in the latest data. So I'll go back into our data factory in here. So it's picking up. Let's see. We have what's the latest one? Let's preview. In the preview, we have the rank. So this is okay. I just need to rerun this, validate all. It's okay. And we trigger this again. I don't think we ran this the last time. We only ran it once, and that was the initial one that we did. We didn't update the data. So it looks like we were still working with the previous data. That was an oversight. My bad. So we do a refresh. I think this is done now. And let's see in our we don't need this. We just go back one step up into the ready folder. Okay, in the ready folder we have this one that is the latest data. Good. And in our Synapse, we are going to bring in the latest data. Okay. From Data Lake, the stadiums, the link service, impute football. Okay. I just click on that. Ready. Stadium clean. Okay. And we can continue. So now we can preview. And perfect. So it's good. So now we can select infer column names, which is the first guy, and we can create. We shouldn't have any issue this time around. This is because we don't have any column missing. Perfect. So now that this is fixed, we just need to, our columns are fine. We don't need to format any of them. You can see our capacity is changed to long, which is good. The rest is fine. Excellent. So we just need to publish this. So now we have the data. Then we just, what else is, we don't need to publish the script for now. We can work on the script much later. Good. So now we have a database. We have a table. I think I need to refresh this part. We have a table. Good. And these are the columns. Good. If I run a select star from stadiums and I run this, oh yeah, before I do that, we need to select the database that we want to be running against. This is by default the master. We need to select the stadium and we are connecting to the built-in. So if you want a separate pool to be added to your system, it's fine. But I'll just go along with the built-in. It's fine. So, but most people select, for more faster queries, you can manage your pool and increase the size of your pool. It's fine. But for me, I'll just stick with the built-in. I think it's fast enough. We don't have too much data to worry about. All right, so you can see the data we have. You can see the chart. This doesn't really make too much sense, because we don't have everything is just packed up in there. So what I want to do now is we are going to be running several queries against the stadium's DB table to see the different aspects of the systems and how to, interact with this. So if you are not so familiar with SQL, I think now might be a time to pick up one or two classes on SQL, right? And if you want me to have a session on SQL, just let me know in the comment section. So we can have the different queries that we can run. These are sample queries, but I'm going to go a little bit deeper into more complex and advanced queries. So if you are like a SQL guru, you can just maybe skip to those parts. But if you are still a beginner, you can just quickly catch up one or two things with beginner, medium, intermediate. You can pick up one or two things from here. So I'm going to be looking at the top 5 stadiums by capacity. Okay. So we can do select top 5. Let's say I want to select the rank, the stadium, then the capacity from, let's say, stadiums, and order by capacity in descending order. So what I'm doing right here is to get these 3 columns, okay, and I'm ordering them by descending. So we are looking at the highest first, the top 5, from there. So it looks like the Rongado First Main Stadium is the one with the highest number of capacity. And we can increase this to, let's say, top 10. You can see the top 10 stadiums from there, which is fine. If you want more complex, a little bit more complex, let's say we want to look at the average capacity of the stadiums by region. So we want to see in each region, what is the average capacity of all the stadiums. So if you have 5 stadiums in a region, what is the average of each of them? And you know the average, the formula for average is the sum divided by the count. Okay. So basically with SQL, this came to mind. You can't use something like a limit in here because this is MS SQL, right? You are not using something like MySQL syntax or PostgreSDB's syntax. You are using MS SQL, really. So I think you should put that in at the back of your mind so that you don't use the syntax for Postgres or MySQL with MS SQL. So we're looking at the region and we're looking at the average. So some window function works with this, not all of them. Something like mediums doesn't work, I know for sure. I don't know if they will be adding support for that, but for now, it looks like it's not working. So, but something like average, sum and basic stuff on window functions, they work on Azure Synapse in here. So we have the AVG capacity. So we are looking from stadiums, and we are grouping by the region. So we can order by average capacity in descending order. So we are looking at the regions and the average of all the stadiums in each region, and we're ordering them by the highest. So it looks like the North America is the one with the average capacity, with the highest average capacity. The rest are, and the list is South America. Well, as at the time and the information available on Wikipedia. So more scripts, we could have something around, let's say we want to count the stadiums in each country. If you want to know the number of stadiums, count the number of stadiums in each country. We can say select country, the count of country, which is going to be stadium count from stadiums. Then we can group by country and order by. I'm sticking to the upper cases so that it's easy to distinguish the keywords from the normal SQL syntaxes. Okay, stadium count. All right, so if I run this, you can see the country and then the number of stadiums in there. So if I order this descending order, I think by default it orders by ascending. So by default, if I order this by descending, you can see United States have 41 stadiums, and you can also say descending. Okay, so let's say something like Morocco, Mexico, and France and India, they're having the same. You can also add additional sort, which is going to be, let's say you want to sort by the country next. You can also sort by the country. So in this case, France comes first before others. So if you look at the 7, you see France, India, Mexico, based on the letterings there. Another example of scripts you can run, you can say you can have stadium ranking with each region. Now we are going into the advanced section, which is where we are using more window functions. So if you don't know so much about window functions, this might be a time to pick up one or two things from here. So what I want to do is we want to say in which region we want to rank based on the capacity of the highest stadiums. So let's say in Europe, we want to get the highest stadium with the highest capacity in Europe. All right, something like that, and across each region. So we have region, I have stadium, and I have let's say maybe I should add a rank to this. It's okay. Rank stadium. Now, I can now have rank itself, which is a keyword or a window function, over and partitioning by the region over the capacity, or that by, not over, or that by the capacity in descending order as my region rank. So what happens is in each region, based on your capacity, you'll be ranked from, let's say, 1 to infinity, to the number of stadiums that is in that particular region. So let's run this and see what the output looks like. So in Africa, the one with the highest size is the new administrative. I think this is in Egypt or somewhere like that. And the rest, you can see each of them have, and these guys, it looks like these guys have the same capacity, so they are assigned the same rank. But anyways, you get the point. So if you want to see the size, which is the capacity of each of them, I think you can add that to it and you can run. Yeah, I need to add comma. I just run this again and you can see the capacity. So these are 80,000, and that's why it is assigning them the rank 4. And as the sizes goes down, it keeps ranking them. So if you want to see, let's say the top 10, the top 3 stadiums for each region, maybe 10, I don't know, 10 is too much. Let's say the top 3 rankings. Okay, so once you have this capacity, you are ranking that, you can now say where region rank is less than or equals to 3. So in each region, this will return yeah, we can do this and we can run. I think instead of running that directly, I think I'm going to just wrap this up, and inside this region rank, and I'm going to select that from here. I was thinking I could run it directly from there. I'll close this as and this is going to be ranked stadiums. Okay, where region rank is less than or equals to 3. All right, if I run this, I think this should fix it. Yep, good, it does. And you can see in each region, which is each of the regions, you can see the sizes of each of them. So you only have the first 3, and when they have the same sizes, you can see there are no okay, something like this. You can see Southeast Asia, is it South Asia, is returning 3, even though we are saying the top 3, but because the sizes are the same, it's returning more than 1 record. That makes sense. So yeah, that's how to work with that. So let's go into a little bit more complex function and functionality from there. So let's say we want to see the stadiums with capacity above the average. So in the world, we have a total average of, in our list, we have an average capacity for all of them. We now want to get the stadiums, only the stadiums that are above that capacity. All right, so I'm going to have 2 selects where I'm going to be joining together. So I'm going to have stadium, then maybe I can have the capacity from stadiums. This gives me the first part. Then the second part is where I compute the average. I'm going to be doing select. I'm going to put that in a bracket. I'm going to have region. I'm going to do an average of the capacity across board, and that's going to give me average capacity from, no, still in the same bracket, from stadiums. And this is going to give me, I'm going to group this by the region. I'll call this T2. This is the table 2. Then I'm going to do a join where the T2.region and it goes to stadiums.region. Okay, so these are the two equals to, and the capacity is greater than average capacity. So I just need to add the region, T2 the region. Doesn't matter whether I use the stadiums region or the T2 region. Doesn't matter. What matters is I can't use the region because both of them have regions in them in both of the tables. So it's going to be ambiguous. And I think I can have the average capacity. So yeah, so this gives me stadiums with capacities above the average. If I run this in valid column name, yeah, of course, it's not capacity, it's capacity. I know most of you caught that. Yes, okay, so you can see what I have in here. I have the stadium, I have the region, and I have the capacity, and you can only see the capacity, the stadiums that are above the average capacities. Any other ones that are less than that are not going to be represented in here. And finally, the final scripts that I'm going to be writing on this part before we move on to the Tableau section, where we where we are going to be designing the dashboards, is this one. I'm going to have the stadiums with the closest capacity to regional medium. So what happens is this. Let me paint a scenario. Let's say in Africa, the median or the average capacity of all the stadiums is 50,000. Okay. We now want to see which stadium is closest to 50,000 as the median average. So the closer you are to 50,000, the higher or the lower your rank, which is going to be something like 1, 2, and the farther you are from 50,000, the higher your rank, something like 10 up to upward or something like that. That will make sense once I finish running. Now you can see the result. So I'm going to have a CTE, and I'm going to call it median CTE as is it? So what I'm doing here basically is I'm getting the rank, two things. I'm getting the region rank by running this query. So this is going to get the median rank, which is more like the average rank, or the median, not average, the median rank of all the stadiums in a particular region. The median and how far you are from there is going to be determined by the absolute difference between your stadium as your capacity as a stadium against the median capacity. So again, to say that again, I have a list of stadiums. I'm getting the median, and I'm subtracting the value of the capacity of each stadium. Based on that, I'm using that as my rank. Okay, if I run this again, it says invalid line 40, region rank. Where is region rank coming from? So I have rank stadium is median rank, not region rank, because that's what I have in here, median rank. So I just will run this. Yeah, so what is happening is this. I think I should probably add the capacity, the median capacity here. So I think I should just add that to this. This is going to be m dot median capacity, and I had a comma to that, and I can have the ranked stadium before the rank. I'll just put that in here, and I'll say ranked stadiums dot median capacity. Okay, if I run this again, I should be able to see the median capacity, and you can see the median capacity is this. Yeah, so that's the end of this part. I think the next part is going to be where I'm going to be designing the dashboards on Tableau. All right, you can use any of the visualization tools that you have, like Power BI, like Looker Studio, or Tableau if you like. But I'll be using Tableau. It looks like we can do some more things with it. So, but by the way, this script is going to be available on GitHub. So if you are interested in copying them, or you want to, revise the script, you can do a copy from there. It's available. Now that we have come to the end of this section, a quick recap of what was done in this section. We were able to pull in data from Apache Airflow into our Azure Data Lake, and we're able to manipulate this data by using the integration service provided by Azure Data Factory from the raw data that we have into some ready format, even though we didn't do so much transformation on that particular data. And once that is done, we were able to integrate Azure Synapse on that particular data, where we can run multiple queries on this data. The data and the queries are all available on GitHub for your use, and you can use that, at any time you want. So in the next video, we are going to be using this same database, or this same data that we have on Azure Data Lake on Tableau. Don't miss it. It's going to be a very interesting tutorial. So I'll see you in the next one. Thank you.